Hi, in this video we'll talk about text and variables that can store text in the C language. There are essentially two ways to store text in C. We can store individual symbols or characters, for example A, or we can store a bunch of characters, also known as strings of characters, for example hello. In this video we'll talk about both of them. You might remember from the previous video that to store an integer number in C, we need to use a variable of the type int. To store a single character, we use a variable of the type char. Let's declare a variable of the type char and name it C. We can assign values to char variables. When assigning a character to a char variable, we must enclose the character in single quotation marks. Let's assign the variable C the letter A. We can print the value of a char variable just like numbers using the printf function, and just like with numbers, we need to explicitly tell the computer that what we want to print is a character by providing a special instruction. The C stands for character. Now, if we run the program, it will print A. What else can we do with characters? This might be counterintuitive, but you can add and subtract characters. Let's see what will happen if we add 1 to the variable C. The program outputs the letter B. If we add 25, the program will print the letter Z. You might have realized that what's happening here. Whenever we add a number to a character, the character changes alphabetically, meaning that adding 1 to a character will change that character to the next letter in the alphabet, well, at least in the examples that I've just shown you. Now let's see what will happen if we subtract 1 from the variable C. The program prints an accent mark which doesn't really belong to the alphabet, at least not the English alphabet. In other words, the alphabet that is used in programming is somewhat different from the English alphabet, or any other alphabets for that matter. The alphabet used in programming is called character encoding table or character encoding system. The system used in the example on the screen is called ASCII. What character encoding systems do is they assign each character a numeric code because computers only understand the language of numbers. What you see on the screen is called the ASCII table. You can see that the lowercase letter a that we initially assigned to the variable C has the code 97, and immediately before it is the accent mark that we got printed when we subtracted 1 from the variable C. In other words, characters in programming are in fact numbers that get displayed as characters. So if you change the instruction given to the printf function and tell the computer to display the variable C as a decimal number, it will print the code of the character stored in the variable C. It is not very convenient to operate with single characters only. For example, if you want to print hi using a char variable, you will need to do something like this. But it would be even more annoying to do something like that for longer words or even sentences. To operate with text of more than one character, we can use a different data type, which in a nutshell is just a bunch of characters. In most programming languages, such a bunch of characters is called a string of characters, or just string. You might remember from the previous video that 1 and 1 inside quotation marks are two different things. Likewise, A inside single quotation marks and A inside double quotation marks are two different things for computers. The first one is a character. The other one is a string of characters, even though it consists of only one character. So characters go inside single quotation marks, while strings go inside double quotation marks. To declare a variable to store a string of characters, we need to add a pair of square brackets right after the variable name. Inside the square brackets, we need to specify the maximum number of characters that the string can store. Let's do 10. There is a problem with this approach. To see the problem, let's try to assign a value to the variable. Let's do hello. The problem is that we cannot assign a value to this variable just like we did with int and char variables. But we can assign a value together with a declaration in one line. In this case, because there is no semicolon between declaration and assignment, both are treated as a single instruction and Replit doesn't throw any errors at us. Now, what can we do with strings? Surprise, surprise, we can print them. To print the value of a string variable, we need to specify that what we want to print is a string by providing this instruction. The S stands for string, as you've probably realized. There's another thing we can do with strings. Because a string is a bunch of characters, we can access those characters modify them, or you gotta print them. To do that, we need to designate which character we want to access by specifying its position or index in the string. It's important to know that in programming, indexing starts at 0, so the first character of a string has the index of 0. Let's print the first character of the string s. To specify the index of the character, we need to write it inside the square brackets that follow the name of the variable. And again, because we now want to print a character, we need to change the way we want the computer to interpret it back to character. And it prints h. Now let's modify the second character of the string s. The second character has the index of 1, and to modify it, we can use the assignment operator. Let's change it to capital E. If we now print the entire string s, we will see that the E got capitalized. Also, because our string s can store up to 10 characters and the current value hello is only 5 characters long, we can add another character to it by modifying the sixth character of the string s. Let's add an exclamation mark after hello. And now we get hello with an exclamation mark. Before we wrap up, I'd like to mention a special character that some of you might have noticed in the previous videos. I'm talking about the backslash followed by the letter N. This is a new line character that tells the computer that anything printed after this character must be displayed in the next line. Let me show you an example. Let's separately print first line and second line. As you can see, the strings got jammed together. However, if we add the new line character at the end of the first string, the strings will be printed in two separate lines. Now let's summarize what we covered in this video. Text in computers can be presented in two forms: individual characters and strings of characters. Characters are effectively numbers that just get displayed as characters using a character encoding system such as ASCII. Strings can consist of multiple characters, and each of them can be accessed and modified. Now, so far we've been using only one function, printf, which prints or outputs data to the screen. In the next video, I will introduce another function that can do the opposite, read or input data from the screen, the data that we type using a keyboard. And this is it for this video. See you in the next one. Bye.